I'm Professor Rad's calculator, and this is Precalc video 211, graphing polynomial functions on a graphing calculator. In this video, we'll be graphing a polynomial function on this TI-84 Plus. This is like the old school graphing calculator that I used back in my day. It's pretty much the same thing actually as the TI-84 CE. The only difference is the TI-84 Plus is a little bit chunkier and it's in black and white. The CE is the color edition. So the menus and the ways to access those menus should all be very similar. If you have a TI Inspire, that's going to be quite a bit different from the 84 Plus. I mean, there are some similarities, but the menus are different. So you'll want to consult your user manual for those, since we're only doing the 84 Plus in this video. So we're going to graph a polynomial function, and then we will learn how to adjust the window for the polynomial function, so we can change what parts of the graph we're seeing. We'll also look at how to identify the x-intercepts and the y-intercepts and some turning points, and just lots of good stuff. Evaluate it for specific values. So let's just go ahead and get started here. We're going to turn the calculator on. And in this video, we're going to be using these buttons up across the top for most of what we're going to be doing. I'm pretty much going to ignore this middle button. You can use it. I mean, there's nothing wrong with it. But for purposes of this video, we're going to focus primarily on the y equals button. That's where you're going to enter your functions. The window, which is how you can adjust the window that you'll be seeing, like change your x and y axes. It's like your axis setter. We'll also be using the second window menu, which is the table set. So that allows you to see different tables of values. The trace button, you could use trace to kind of trace along the function and get values that way. But mostly we're going to use the second menu here. So that's the calculate. So anything you see in blue above these buttons is going to be accessed by hitting the second key and then that particular button. So we'll use the calculate menu a lot. We'll also be using the graph button because we'll be looking at the graph of this polynomial, and then as well as the table. So the table is going to give us specific values that the polynomial is evaluated at. So let's get started by typing in a polynomial. So I'm going to hit y equals. And my calculator is going to be stubborn. So we'll hit y equals. There we go. And here is the list of our different functions. So I'm going to enter in my polynomial function, which is in factored form. It's going to start out with a -2. And then we have a parentheses, x plus 3. So this delightful button here with the x, the t, the theta, and the n, that's your variable button. So we're just going to type in x plus 3, close those parentheses. And then we have another factor. This is a quadratic factor. So it's going to be x squared minus 4x plus 1. And that whole thing is cubed. So I'm just going to use my exponent button here. That's that little caret, and put in the 3. So this is our polynomial function that we're going to be graphing. And yeah, so let's graph it. So I'm going to press the graph button. Now, if you have other functions already in your graphing calculator, you may need to clear them out. And your window might be different from mine. Mine is at just like the default factory settings window. And I can tell this is not a helpful view of this polynomial. I don't even know what's going on. It's just a bunch of lines, it looks like. So I'm going to need to adjust my window if I'm going to understand this polynomial better. So one thing that I do notice is that it seems to be focused close to the x-axis here. So I can probably narrow my x-axis window, but my y-axis, I'm going to need to expand that because it's clearly going off above someplace and somewhere down below as well. So I'm just going to make like my best, not really educated guesses here to how to adjust the window. So I'm going to go to the window setting. And this is the default factory setting from -10 to 10. So what I like to do, I'm going to set this one for -5. So x min is the lowest value your x-axis will go to. So I'm going to set that to -5. and x max is the largest value your x-axis will go to. So I'll set that to 5. Now for my scale, I'm kind of particular as a human being when it comes to my scale. I like having like the standard number of tick marks that your graphing calculator wants to do. So it wants to do, like, if you have a symmetric axis, 10 tick marks below and 10 above. So if you're interested in kind of maintaining that, I'm going to set this to my maximum 5 minus my minimum, so minus -5. And then I'm going to divide that by 20. The reason I'm dividing by 20 is because that'll give me the 10 above, 10 below. And then I'll just hit enter and it'll calculate what that is. That's 0.5. So I'm going to do something similar for the y-axis, although this time, instead of narrowing the focus, I'm going to expand it quite a bit. So my y minimum, I'm just going to go with -500, and I'm sure I'm going to need to adjust that, but that's where I'm going to start. And for my x maximum, I'm going to do the same thing, 500. And for my y scale, again, this is going to tell me how frequently it'll put a tick mark. So I'm going to do 500 minus -500 over 20. There we go. Okay, 50. And then x-res, this is the resolution. It tells you like how precise the graph is going to be made. So if you go too far with your resolution in one way, basically it'll take too long for the graph to load. And if you go too far in the other way, your graph might be like really disjointed or not as precise. So I just always leave mine at 1. I don't ever mess with it. Seems to be fine. So now I'm going to go to graph and graph on this new window. Okay. So it looks like we have, this looks like a little person with, like, they're holding their cape up over their face, and then they've got their little hat peeking above. I don't know, that's what I'm seeing here. But on this graph, we can see that even setting it from -500 all the way up to 500 was not enough to catch what's going on down over here. But the good news is we do get to see this turning point here. Now, I'll remind you that on the x-axis, this is like 5 all the way on the end. So each of these tick marks represents a half. So it looks like this turning point is happening at, I can't see very well from where I'm sitting. So yeah, maybe that's 1, maybe about 2-ish. Yeah, or so, maybe like 3, I don't know, something like that. So, so if I want to know exactly where this turning point is, I'll show you how we can find that out. And I really need to know where this turning point is so I can adjust my window accordingly. So let's do that. Let's figure out how to find out where turning points are. To do that, we're going to use this calculate menu that's right above the trace button. So to get to that menu again, since it's in the blue, we're going to hit second calc or second trace. That'll give us our calculate menu. So second trace. And we're going to be going through a lot of these functions. Oof, I'm so sorry. I just kicked my table. So anyway, we're going to be going through a lot of these different functions, including value, 0, minimum, maximum, and intersect. So those first 5. What you see here on my calculator is options 6 and 7. Those are calculus options. So you may see those next semester in Calc 1. For right now, let's figure out where that turning point is that's off screen. So that looked like it was going to be a minimum. So I'm going to go to option 3. And you can either hit 3 or you can scroll to 3. Now, for most of these options, what your calculator is basically doing is it needs you to tell it a little range so that it knows where you want it to be looking to find the thing it's going to be looking for. So what it's saying here is, please tell me a left bound. So tell me like the left edge of where I should be looking. So the turning point's happening somewhere down here. I'm going to say it's probably around like 2 or 2.5. So for my left bound, I'm going to type in -3 and I'll hit enter. Now, when I did that, it put a little spider here to indicate that that's what I had put as the left bound. Now it's going to tell me right bound. So again, I could type in a specific number, so I could pick like an X value of 0, or I can use my arrows and kind of scroll that little spider. Like went so far off screen we lost it, but if I continue to go to the right, at some point it should reappear. Yeah, there it is. Okay, so you can pick your right bound and your left bound either by scrolling or by typing in a specific number. So I'm just going to select there. What's really important, you see these little triangles up here at the top. What this is saying is my turning point has to happen somewhere to the right of this and somewhere to the left of this. And it does, it's somewhere in between there. Now that we've set our boundaries, it's going to ask us for a guess. The guess isn't really important. Really, the purpose of the guess is if you have a really wide interval, if your guess is close to the answer, then it might take your calculator less time to compute. So I said it was pretty close to -2 or -2.5. So I'm going to guess -2.5. But as long as my guess is in between my left bound and my right bound, it doesn't matter. It'll be okay. So it's telling me that my minimum is happening when X is about -2.383. And the minimum value, holy cow, is -5,256.779. So both of these are rounded values. They're approximations, but they're going to be the best that we can do right now. So this means if I'm going to adjust my window, I have to go down to -5,256. Oh my goodness. Okay, so definitely going to have to expand my window. So let's do a similar thing. Let's figure out where this turning point is up here. So because this turning point appears to be a maximum, I'm going to hit second trace to get to my calculate menu. And this time I'm going to go for option number 4, maximum. So I can get there either by pressing 4 or by scrolling to 4. I'm going to hit enter. Now, again, you can pick whether you want to scroll or whether you want to pick a specific number. So like I can scroll the little spider over and you can see it's telling me X values and corresponding Y values. There it is, finally made its appearance. So this time I'm going to get real close to that turning point. So I'm going to guess this is before the turning point happens on the left. So I'm going to put that as my left bound. Then I'm going to scroll over here just after the lump for my right bound. Then I'm going to scroll somewhere in between, pretty close to that turning point. Again, you don't have to be super, precise with this. Just do your best and the calculator will figure it out better. So our maximum value is happening at about 2.097 and that Y value is 272. So based on this, it sounds like I have to adjust my y-axis quite a bit so that it goes down to -5,000, what was it, like 200 or 300? And it's got to go up, I would say at least to like 300. So I think I'm going to do -5,500 up to 500. But again, you could do, something a little bit different as long as you include all of those important points. So now I'm going to go back to my minimum and I'm going to set it -5,500. My Y value is 500. And I'm going to do the same thing for my scale. So I'm going to do 500 minus the -5,500 over 20. Okay, and then we'll hit a graph. So we can see now we have substantially more space in our negative y-axis, and we can see a little bit less detail up here. So it was nice that we had that other window so we could see more detail of what was going on up here. But now we can also see kind of what's happening with the bottom edge of this curve. So far we've gone through adjusting the window, and we've also gone through finding the minimums and the maximums to help us adjust that window. Let's look at the x-intercepts. Let's look at those. So if I want to find the x-intercepts, it looks like this function has 3 of them. So we have one all the way to the left, We have one really close to 0, it looks like. And then we have this one over here, which is after that turning point. So let's go ahead and try and find this x-intercept first. Now, I know that this x-intercept is going to be -3. How do I know that? Well, when I look at the equation of our polynomial, we had a factor of x plus 3, which means -3 is going to be one of the x-intercepts. But let's just confirm it, make sure, since we have one that we know, let's use this process to make sure we can check that. So I'm going to go to my calculate menu again, so hit second trace. And you can see our second option here is for 0. So the 0 is going to tell us our x-intercepts. So you can either type in 2 or you can scroll down to 0 like I just did. And just like with the turning points, it's going to ask for a left bound, a right bound, and a guess. So I'm going to put in a left bound of -5, a right bound of 0, and my guess, I'm going to put in -2. I know it's -3, but let's just see what happens if I put in a weird guess. See, it finds it anyway. So it's going to highlight it with a little spider here. I don't know why I call that a spider, by the way. That's just probably because my math teacher called it a spider and it just stuck. And then it tells you that your x-intercept is at -3, 0. Cool beans. So let's see if we can find this one up here. So because this one is so close to the y-axis, I think I'm going to set my left bound to be 0, and then my right bound to be about 2, because I know that's where the turning point happens. So I know this intercept is somewhere before that turning point. So let's go back, second trace, and let's find a 0 again. This time for my left bound, I'll choose 0. And for my right bound, I'll choose 2. And for my guess, I'll just pick 1 because it's between 0 and 2. Okay, so it did its calculations and it got about 0.267494919. So that's our x value of that x-intercept, and then it has the y value of 0. All right, and lastly, let's figure out this x-intercept over to the right. So I think I'm going to use a left bound of 2 and a right bound of 5. But again, you can feel free to scroll when you find your bounds. So let's get our 0 going. So like if you want to move that spider and scroll through, you can absolutely feel free to do that. I just prefer typing in numbers. So I'm going to do 2 and 5. And my guess is going to be 3, because 3 is between 2 and 5. Again, the value of your guess doesn't matter so long as it's between the lower bound and upper bound that you stated. So here we have our x value of about 3.73, and our y is equal to 0. Now, I will mention sometimes your calculator won't have 0 here. It depends on just your calculator's mood, really. I mean, it depends on your resolution and your scale and all that kinds of stuff. But I like to think it depends on my calculator's mood. Sometimes it'll put something here in scientific notation that's awfully close to 0. So if you see something like 3 point a bunch of nonsense, and then it has like e -20 or something like that, that means that your calculator's putting a very tiny decimal super close to 0. And that just happens from like round off calculations that your calculator is doing in the background. All right, so that's how we find our x-intercepts. Now suppose I asked you to calculate specific values. And let's say I wanted you to find specific values that were like half a point apart. So if you have a lot of values that are at regular intervals, we can use our table to do that. So if I hit second graph, that's going to pull up the default table. And so I can see here, these are my x values. The default table starts at -3 and goes up to 3. But you can scroll up to get lower x values, or you can scroll down to get higher x values. And you'll see in that column that says y1, those are the y values of your polynomial function. So you can also use your y1 column to help you figure out lower bounds and upper bounds for x-intercepts. For example, I notice over here that at 4 we have a negative y, and at 3 we have a positive y. So that means the y-intercept has to be somewhere between 3 and 4, right? So I can use that to help me set my lower and upper bounds. So that's another technique you could use if you wanted to, other than just the graph. But let's say I wanted to know, like, well, what is y when x is negative 0.5? If I scroll up on my table, it's only going by whole numbers. So a way to adjust my table, the interval that it's changing, above the window button, we'll see in blue, it says table set. So we're going to hit second window, and this will adjust the table intervals. So table start is going to tell you that number that was at the top of the screen here for your x. So let's set this up so it starts at -2. This little triangle stands for delta, that's change in. So change in table, let's set that to 0.5 so we can find some values that are at 0.5. Now the independent and dependent variable, I'm just going to ask you to leave those on auto. You can put the independent at ask, and what that will do is it'll enable you to type in specific x values, and then it'll calculate the y value. So I'll show that, but you don't need to use that one at any particular point. So let's go back to the table now. And now we can see that the change in the table is now by 0.5. So like if I wanted to know the y value when x was a -0.5, now we have that available, and we can see that the y value is like a -171.6. And then if I wanted to know what it was at 5.5, I can just scroll down until I get to 5.5. Now, I'll also point out that this column only is so wide, so you can only see so many digits. If I wanted to see more information about this value, I can just hop over to that column, and notice now it's displaying a longer decimal here. So if I were to ask you a question about evaluate this function at 5.5 to the nearest hundredth, you could just scroll over to that column and then use that to help you out. Okay, so let's see what happens if I were to, let's say I wanted to see like, well, what do I get when I evaluate at pi? So I'm going to show you how you can use that in your table. So let's go back up to the table. And I'm going to change this independent to ask. So this is one way you could do that. So let's go back to our table. And now, oh, excuse me. Now you see that the X column and the Y column are both empty. So I'm allowed now, my calculator is like, well, tell me an X, and I'll tell you the Y. So let's say I wanted to know what it was for pi. I could type in pi. So that's going to be second caret, and enter. And it'll calculate right here. Now, personally, I don't like this method because I like to keep my table populated with a variety of values because I like to be able to scroll through that, and I don't want to have to change that a lot. So I'm going to change this back to auto. But if you like that, you can use that method. Here's another way you can figure it out. So if I go to second trace to my calculate menu, I'm going to choose option 1, value. And now it's going to show me my graph again. And here is where I can enter pi as well. So I can also enter in a particular value here on my graph, and then it'll tell me the value here. So you could use, set your table to ask instead of auto, and you could figure out the y value when x is pi using the table. Or you can go to your calculate menu and go to value, and that's another way you can figure this one out. So it's really up to you which way you prefer. Okay, so now if I gave you a specific x value, we can figure out y. What if I want to know the opposite? What if I tell you a specific y value and now you have to figure out its corresponding x? So to do that, we're going to use the intersect function from our calculate menu. So let's say I want to know, okay, so this is the y value when x is pi. What if I want to know, well, at what x value will y be pi? So I'm going to go to my y equals, and I'm going to scroll down to my second function here, so y2, and I'm going to enter in the constant function y equals pi. So if I wanted to know, okay, for what values of x does my function equal 15, then I would just type 15 here. So whatever y is equaling, that's what I'm going to type into the second equation. And now I'm going to graph that. And the graph doesn't look any different. So what I'm going to do, I'm actually going to shorten this y-axis because I want to see what's happening up above close to pi. So let's change our window here. And let's go from 0. I'm interested in pi, which is close to 3. So let's just go to 10. And we'll mark that out by 0.5s. And now let's graph that. Okay, so these vertical lines, remember, these are pieces of our polynomial function, and we now know that it's turning around down here, and then it turns around up here pretty far away. This extra horizontal line that has been graphed, that's the line y equals pi. So we can see that our function hits that line in 3 different places. So that means we're going to have 3 solutions to the equation y equals pi. So let's try and figure out at what x value this one is happening. So to do that, I'm going to go back to second trace. So I go to my calculate menu. And this time I'm going to go to intersect because I want to know where does that horizontal line intersect my polynomial. So I'll hit enter. Now this time, instead of asking for a left and right away, it's going to ask you for first curve, second curve. So let's see, if I move my cursor a little bit, right now I think it's tracing the polynomial. So it's going to be hard for me to look at these really big negative y values, right? So it's tracing my polynomial function. So I remember that turning point happened after like 2.5, right? Yeah, in fact, it intersected at 3. Now it's going super huge. Okay, so the first curve, it's clear that it's going along my polynomial because it's giving me all these wacky numbers. So I'm just going to hit enter. And then second curve, here we go. Now you can see the little spider is going along that horizontal line. So what was happening with that first curve part is it was down under here going along the polynomial. And then this polynomial increases so quickly, it didn't even go on the screen. We didn't even see the spider. It jumped so fast. But now we can see that the little spider is tracing this horizontal line. So that's our second curve. So we're going to hit enter. And now it says guess. So I'm going to scroll over to that intersect we were interested in. And yeah, let's just guess this piece. And again, it does its little calculation. We can see the y value now is pi, 3.14. And it says that it happens really close to -3. Oh my goodness, so close to -3. And that kind of makes sense because this function's increasing so quickly and we know it hits the x-axis at -3. So it's going to hit 3.14 pretty close to -3. And then we can do the same process to figure out where this point is and where this point is. So I'm going to go to second trace and I'm going to go back to intersect. It's already on the 2 curves I want it to be on. So I'm just going to hit enter. And now I'm just going to scroll all the way over here. Oh, it's pretty close. There we go. So we see now it's going to be about pi, pretty close to 1/2. And then we can find this one here as well by going second trace to get to our calculate menu. 5 for intersect. It's on the polynomial. So here we can see it. It's actually on the polynomial function. So that's our first curve. Now it's on the horizontal line. So that's our second curve. And then we're just going to scroll all the way over to this one here. There we go. So now we can see once again that y will be pi when x is about 3.5. So there you go. That's how you can find x values for a particular y value. All right, so that's going to wrap it up for this video on graphing polynomial functions on a graphing calculator. So hopefully it was a little bit helpful to you to figure out, first of all, how to graph the polynomial, but then also how to find its turning points, adjust your window, adjust your table, and calculate some specific values. So in our next set of videos, we're going to start talking about rational expressions, so fractions of polynomials. So you can look forward to that. In the meantime, I hope you have a wonderful day, and I'll see you soon. Bye for now.